I'm going to call this video, get the hell out of here. There's no way. This guy's going to show you an
Yes.
eclipse that I think just can't happen on a globe model like we're
December
taught.
10th, about 6:30 in the morning. It's about 18 degrees out here, and we're standing on top of Cahokia Mounds, just east of St. Louis. Behind me is a full moon, which will soon be.
As you can see, the
going
moon in the
into
background
a
hasn't been eclipsed yet.
full lunar eclipse as it sets.
This is a
As a lunar
Selenian
experience,
eclipse.
while at the
Try to
same
say
time
that 3
behind
times
us,
fast.
the sun
As you can see, the sun is coming up in the background at the same time.
a very interesting and beautiful experience.
Okay, so here's the eclipse. Now, if you look at the eclipse, it's eclipsed the wrong way. The sun is rising, and the Earth should be blocking the bottom of the moon, not the top of the moon. So it doesn't make any sense. Now watch this guy try to explain it. It's kind of funny, actually. I got to give him credit because he got up early, and he's, doing his thing.
The moon there, we can still see it just a little bit. What I find very interesting is I was expecting the shadow to come upward across the moon as it would go down and it would pass into shadow, and actually it's going the other way around. The shadow, as the moon is here, the shadow is creeping down across the moon, even though the sun's coming up over here, and that must be because of the moon's rotation around the Earth. It's moving farther up, even though the sun's light is actually coming from over there. It's actually coming underneath the Earth. So if you imagine, the sun is here, the Earth is here, and the moon is back here, and this light was coming under the Earth, but the moon must be rotating around even though we're turning, so it looks like the moon is going down. It's kind of an optical illusion. It's pretty cool. So the sun is scheduled to set at 7:08.
Now you can see this guy do his best to explain it, but you can tell that the gears are spinning in his head. And he's going, this shit ain't right, but gotta be right because that's just the way it is. Okay, let's make a model and see what's going on. Okay, so here's our model of our eclipse. And over there is our sun. And here's the Earth lit day and night. See it spins. And down there is our moon eclipsed. Now, technically, let me go down here and show you. Here's a round shadow on the wall, and here is well, it's an Earth, but we're going to call it a moon. Now, it should be on this side, right here. But instead, we're going to give the globe benefit of the doubt, and we're going to put it on this side. This is lit up the right way. Okay, see our little red dot? That's our guy standing in Illinois. Okay, let's move him in the dark area. Now, in the dark area, you can probably see the eclipse. But the eclipse hasn't started yet when he's in the dark area. It doesn't start until he starts coming up towards the light. Now, let me show you.
20 degrees now. You can definitely see the sun coming up now if you want to get one last little shot of that. Just a little blip there.
Okay, here's our guy. And as the Earth turns, the sun comes up. And in order to actually see the sun, like in the video, you got to be at 0 degrees. This guy is not even measurable on this globe. He's like 0.00006, 6/100,000ths of an inch tall. So basically, the guy would have to be at 0 in order to see the sun. So at 0 degrees, let's go look at our CAD drawing and see if you can see the eclipse. Okay, so I got my crayons out. And here's our guy standing on top of the Earth. And he's looking down at the eclipse. And our red line would represent the horizon because it's about a moon away from the horizon. Okay, let's look at it a little closer in real CAD. Okay, here's the Earth to scale. The two yellow lines are the shadow of the Earth. And the red line is the view of the little dude standing on top of the Earth. Okay, let's take a look downrange. Okay, here we are downrange. The two yellow lines are the shadow of the Earth. And you can see the moon is being eclipsed by the shadow. And the red line is the line of the viewer. Okay, let's go back up to the viewer and zoom in a little bit. Here we are zoomed in, and on the left is the little dot that's the viewer. And the red line is the viewing angle. And as you can see, it cuts through the Earth. So obviously you can't look through the Earth to see the eclipse. Well, maybe Superman could look through the Earth, but I don't think that's happening. Okay, let's go back to the crayon drawing. Okay, back to the crayon drawing. If you can't see below this line, that means the moon has to be up here someplace. If it's up there someplace, that means that the sunlight would have to be refracting off this side of the Earth and lighting up this side of the moon. How's that gonna happen? And if the sun was coming up just a tiny little bit, wouldn't the moon be out of eclipse? Doesn't make any sense. And here's another problem. See how the shadow is curved, slightly curved? Here's an eclipse from 2021, this year. As you can see, the shadow is curved. Okay, so here's the Earth with the sun shining on it. And here's my little mock-up moon. I had to find a Christmas bulb with the right dimension to make it to scale. I drew a little equator on it. Now, don't you think the Earth would make a round shadow on the moon? Let's take a look. Here's the moon. Look at this. It makes a perfectly straight shadow. That's crazy. I don't know if they cancel each other out, but I'm going to do it to scale. So we're going to come down here at 30 feet. And I'll show you again. It really doesn't matter how far away you get from the moon. It just gets more fuzzy. See, it's perfectly straight. It's crazy. Okay, here I am about 30 feet away from the Earth. And you can see it makes a round shadow on the wall. And I use a different size ball this time. A little bit bigger. Look at it. It still makes a straight shadow. Unbelievable. You can see where I'm going with this. There's a curved shadow on the moon. Doesn't make any sense. Actually, nothing makes any sense. And why does the moon glow red? What's the scientific explanation for that? Okay, back to the beginning. See this eclipse? Get the hell out of here. There's no way. I don't think the heliocentric model supports this type of phenomena. Once in a while somebody asks me like, well, what is it then? And I'll be like, I know what isn't. Does that mean I know what is? So they're like, well, if you don't know what is, then you're not right. I'm like, shut up. This time I'll take a crack at it. And this is just my opinion. I remember looking into some Egyptian astronomy, and they were talking about celestial body that you couldn't see, but it would give the sun energy. Kind of weird. Check this out. This is a total solar eclipse filmed by a camera crew inside of an airplane. Here's what they recorded from inside the plane. Now check out these little like transparent orb or like a clear disc. Now maybe it's one of these that eclipses the moon. And after it covers the moon, then the moon gives off its own light and turns red. So this could be a good explanation. By the way, we've been predicting eclipses for a long time, way before NASA came around. I hope this video was helpful to some people, and get the hell out of here.